So today we're in one of our homes that's under construction. We're in the rough ends phase or the mechanical phase of the construction process. And I'm going to show you a couple things just so you can see what's going on behind the walls. This is sort of the skeleton of the home. This particular home has 8-foot ceilings, which was what was requested by the homeowners. Some of our homes have 9 foot, some have 10 foot. A standard home, a managed series home, is going to have 8-foot ceilings as a standard feature. Now, I'm going to take a look just for a moment about the exterior walls. Now, the homes that we build today in Illinois are some of the most energy efficient homes in the country. Last year, or I should say in 2012, the state of Illinois and the state of California adopted the National Energy Code. They were the only 2 states in the country to do so. The rest of the states felt that it was too restrictive and far too expensive to adopt. However, Illinois and California, they disagreed. So as we adopted the Energy Code, there was drastic changes made to the building in Illinois. Most home builders were forced to raise the price of their homes somewhere between $7,000 to $10,000. Fortunately for us, we had already been building homes so energy efficient, it required a very small change for Homes by Design. One of the things that we do to achieve this overall energy code, and there's many parts to it, one of the things we do is we have thicker walls. You'll see that all the exterior walls on all of our homes are 2x6 exterior walls. A typical home built would have 2x4 exterior walls. Now there are other things I could do to the home, manipulating this or that, in order to get to a 2x4 exterior wall. I felt for just a little bit more money I could go to a 2x6 exterior wall and make a greater insulation value. I'm actually going to have an R21 insulation value. But if a 2x6 wall, if I can achieve this, not only has it got a better energy rating, but it's also going to be inherently stronger than a 2x4 wall. A 2x6 wall is considerably stronger than a 2x4 wall. So I had an opportunity to actually increase the quality of my homes. I'm actually building a stronger home than I was just a few years ago. So you've got the walls. All exterior walls are going to be placed 16 inches on center. All of our framing is placed 16 inches on center. Exterior and interior walls are placed 16 inches on center. Now an interior wall, these will stay 2x4 walls because there wasn't much advantage to having a 2x6 wall here. The only 2x6 walls you'll see on the interior of the homes are plumbing walls. You will see that all of our exterior and interior walls are lagged to the trusses with lag bolts so that this keeps the trusses from lifting. If you've ever been in a home where the ceilings crack at the top of the wall and the ceilings crack, it's because the trusses are lifting and upheaving. Now there's many different parts to building an energy efficient and quality home, one of which is a window. We all can have heard about energy efficient windows and quality windows. This is one of them. This is a Silverline 2900 series window by Andersen. This is Andersen's vinyl window. And on this window, you know it's a quality window when you look at the NFRC rating, or the sticker that's in these windows. This is going to show you the performance ratings of this window, because it's hard to tell a good window from a cheap window. They're both clear, you can see through them both. It's hard to see value in it. But this window right here has got a tight seal to it. There's 2 panes of glass. It's insulated glass with an argon charge in between it. And argon is an invisible gas that has a very high density to it. Seals up well, performs extremely well. But even the best window can have a defect in it or can be installed improperly. So we take an extra precaution to protect our homes against either a window defect or a poor installation. I have more faith in the installation of my windows than I do in the future seal failing, because sometimes things just happen, you know. But what we'll do is we're going to go around and we're going to put in a waterproof flexible flashing that comes up about 6 inches on each side of it. This flashing is built specifically to work with the Tyvek home wrap that we use. It's a DuPont product. And then that ensures that any water that sits here will not penetrate. We take our window sills and we put 1/8 inch shims in these window sills, creating a very subtle tip outward. Not one that you'll notice from inside of the house, but if this ever were to leak, the water is going to run outside of the building envelope, end up on the other side of this Tyvek. so that the moisture cannot get into the building cavity below the window and cause premature rot. Again, it's highly unlikely that that's going to take place because you're using a quality window in the first place. It's being installed by people who know what they're doing. But what if? If it were to leak, nobody would ever know. No one's ever going to check this. It would just slowly leak and cause premature rot and deterioration of the home. Since we build our homes to last 200 and 300 years, I just don't want that to happen. This particular window here is the kitchen window. The kitchen sink is going to sit right in front of it. Now down below the window, you're going to see the things that makes the kitchen sink work. Here we have the copper supply lines. Still one of the builders that uses only copper for their supply lines, not the PVC. It's something that we believe in. It certainly costs more, but it's a higher quality product, and we know it's time tested. It's true, it works. So we have supply lines here. They've got hot and cold water supply lines. It's going to come up in the bottom of the cabinet and supply the sink faucet. But then the water that comes into the sink is going to have a way to get away. How does that get away? Where does it go? It comes right into here. You've got these two drains, one for the right sink, one for the left sink. Both are going to drain down, come into the main drain, going down towards the basement and then out towards the city sewer. Then this pipe here that my left hand is on, this is a vent pipe. It runs around, goes up outside. This vent pipe is the thing that makes it work. It actually allows air to get into this drain. If you didn't allow air to get into the drain, there would be a vacuum here. It would clog up, and your sinks would never drain. That's a little bit of what's going on with under the kitchen sink. And just in case you do get this thing clogged up, and your kitchen sink's the one that gets clogged more than anything, because people shove potatoes down their garbage disposals, you've got to clean out right here, so that the plumber can come back in at a later date and get into that pipe, run a Roto-Rooter down in there, clean the pipe out, and unclog the sink. This is an excellent example of a standard fireplace unit for us. This is a Nova series. This would be our standard fireplace. Not all of our homes have fireplaces in them as a standard feature depending on the price point, but if you say, Bob, give me a fireplace, by all means I will. This is going to be the standard that we use. It is not the least expensive fireplace. This is not what you would call a builder series fireplace, but it's a little bit higher price point, but it's a great value point. This fireplace would allow you to buy accessories to go on it at a later date and really, really dress it up. The fireplace unit should operate at about 85% efficiency. That's very similar to what a standard furnace operates off of. The way this fireplace operates so efficiently is that it's a sealed unit. This is a glass panel here. It's completely sealed. It's going to get its combustion air from outside. It's not using air from inside the home to feed the fire. You've got a flue pipe here. This is a double wall flue pipe. You have a large pipe and then a smaller pipe inside it. The smaller pipe is for the exhaust. The larger pipe is for the intake air. Because the intake air is coming down the outside, it allows us to install this fireplace in such a way where we have minimum clearances from combustible materials. After this fireplace has been running for an hour, you could put your hand on this pipe here and not burn yourself. As a result, it doesn't get hot. Because it doesn't get hot, we don't catch things on fire. There's going to be a gas line run to it, and all the fireplaces come with a blower motor that's thermostatically controlled, so when the the temperature gets up inside the firebox hot enough, the blower automatically kicks on and increases the efficiency of this unit. This here is an example of some of the ductwork that's used in building the homes. One of the changes they made in the 2012 Energy Code was that they required all your cold air ducts to be ducted. The cold air returns used to be able to run through wall pockets. Now we want them ducted. And if it's a ducted cold air return, it needs to be sealed as well. So this is a custom fabricated cold air return here. You'll see this gray matter is a mastic, liquid applied mastic, and it's going to seal up the ductwork. Everything you got going up here has been taped and sealed as well. And it is an insulated ductwork, which is flexible, allowing cold air returns to come in. All these pipes are going to pull air from different parts of the home, different rooms in the home, back down into this ductwork, down to the furnace system. Again, everything is sealed. We're going to use a 92% efficient train furnace down in the basement. All the ductwork coming from the furnace and cold air going to the furnace is going to be sealed. And that allows this furnace to actually operate at the greatest level of efficiency. it really does work well, and it pays dividends in your power bills. This home here is something we're doing that's a little bit unusual. We're building this home for a family that has a child who needs a little extra help, so we're going to have an actual elevator in this home. This is an elevator shaft, complete with a recessed well in the bottom so that the elevator can come down and get truly flush with the floor, and it's going to make it available for him to go from one floor of the home to the other and participate in all aspects of the family life with minimal inconvenience. You'll notice there's no dirt in here because we're going to fill this void with ag lime or rock or sand. Most of the time we use ag lime, sometimes we use rock. It depends on the market price of the product. Now the subfloor that we use is Advantech subfloor system. I use this exclusively. Until I find a better product, this is what you'll see used on your homes.